Now we're going to talk about the rational roots theorem or the rational zero test. This is going to give you all possible rational zeros. Now they may not all work, but it gives you all the possibilities. The reason that this is important is if we have a polynomial that we're trying to find all the zeros of, in the past in section 3.4, I gave you a factor or a zero to start with that then you could factor out and then get a quadratic that you could factor. Well, you're not always going to be given a starting point, so you need to be able to find your starting point. So the rational zero test gives you a starting point of possible options. So if you're given any polynomial, the last term or the constant is going to be your P, and the leading coefficient we're going to call Q. So the rational zeros test says that the factors of P over Q, or the positive and negative factors of P over Q, will give you all the possible zeros. So it's not just P divided by Q, it's the factors of both P over Q. And it's the positive or negative possibilities. So I know that might be a little confusing, so let's look at an example. If we have 9x to the fourth minus 3x cubed minus 58x squared minus 4x minus 24, we're going to find all the possible rational zeros. That doesn't mean they have to work, it's just the ones that might work. Our P is negative 24, and our Q is 9. So my possibilities are plus or minus. I'm just going to put 24 here. You don't have to really worry about the sign because you have plus or minus. So it gets the negative and the positive of that number. So the sign doesn't matter here. And then you divide that by 9. So these are the factors of 24 over the factors of 9. So I got plus or minus. My factors of 24 are 1 and 24. 2 and 12, 3 and 8, and 4 and 6. So those are my factors of 24. And then the same thing for my Q. My factors of 9 are 1 and 9, and 3 and 3. Okay? So now you're going to divide everything on top by each of these numbers on the bottom. So starting with 1, everything divided by 1 just gives you all the whole numbers. So all our possibilities, let's start with our whole numbers. We got plus or minus 1. And I'm not writing plus or minus each time, but that plus or minus goes to each number. So I got plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Then you move over to the next number in the denominator and divide each number by that number. So I've got plus or minus 1/3, 1/2. Oh, sorry, not 1/2. 1/3, 2/3, 3/3, 4/3, 6/3, 8/3, 12/3, and 24/3. Now a couple of those are repeats. 3 over 3 equals 1, and we already have that listed. 6 over 3 is 2, we have that. 12 over 3 is 4, we have that. And 24 over 3 is 8, and we already have that. So you can cancel the repeats out. Now we're ready to move over to 9. So we've also got plus or minus 1/9, 2/9, 3/9, 4/9, 6/9, 8/9, 12 ninths, and 24 ninths. And again, you have a couple repeats. 3 ninths reduces to 1/3, and we already have that. 6 ninths is 2/3, we already have that. 12 ninths is 4/3, and 24 ninths is 8/3. So all our possible zeros are all of these whole numbers plus or minus each one. The 1/3, positive or negative, 2/3, 4/3, 8/3, 1/9, 2 ninths, 4 ninths, and 8 ninths. Those are all your possible zeros. So you'll have a couple questions on the homework or test that ask for possible zeros. That means it wants this whole list. So pay attention to the way it wants you to fill those in. Some of them it'll actually want you to separate them by commas and do plus, or do -1, -1, -2, -2, or it might ask you to just put the positive or negative out in front of the whole thing. But it wants a list of all of those numbers if it says possible zeros. So let's look at this next one. Same thing. Our P is 4 and our Q is 2. So all our possible rational zeros are plus or minus the factors of 4 over the factors of 2, which will be plus or minus 1 and 4 and 2 and 2. And then the factors of 2 are just 1 and 2. So this one's a little easier. All your possibilities are going to be all the whole numbers when you divide by 1. And then divide by 2, I've got 1/2, 2 over 2, and 4 over 2. Now notice these last two are repeats because they reduced to 2 and 1. So all your possibilities are the positive and negative 1, 2, 4, and 1/2. So that was all the possible rational roots. Now, in this next example, it wants you to actually find all of the zeros. So we did this in section 3.4b when we did synthetic division, but we were always given a zero or a factor to start with. If you're not given one to start with, this is when you are going to use the rational zero test. So nowhere is it going to say find all the possibilities first and then see which ones work. That's something that you need to know. So if I have a polynomial and it doesn't give me one to start with, I'm going to find my P and my Q and find all the possibilities first. So I've got my P is 3, so I've got plus or minus 1 and 3 are the factors of 3. And then I've got the factors of 2 are 1 and 2. So all my possibles would be 1 plus or minus 1, 3, 1/2, and 3/2. Now this is where you just start guessing and checking with all your possibilities. So I'm going to take my function, make sure it's in descending order and there's no missing terms. So I'm good. It's got an x cubed, an x squared, an x, and then a constant. So I'm going to pull my coefficients and just start doing synthetic division with your possibilities. So I'm going to pick -1 to start with. So I bring down my 2, multiply, and add, multiply, add, multiply, and add. Well, if you come out with a remainder that's not 0, that means that it is not a zero of the function. To be a 0, your remainder has has to be 0. So -1 doesn't work. So let's try another one. Let's try 1. Same process. So synthetically divide. Ah, so this one, I end up with a remainder of 0. So that means that 1 is a 0. And now that I've found one of a third degree, that means my answer here is a quadratic. So that gives me 2x squared plus 5x minus 3. And I can factor that to find the remaining zeros. So I've got 2x and x. I just have to figure out where factors of 3, that will give me a positive 5 in the middle. And that, if I put a 3 here and a 1 here, I can get a positive 6x and a negative 1x will give me the positive 5x in the middle. So I've got 2x minus 1 equals 0 and x plus 3 equals 0. This will be, if I add 1 and then divide by 2, I end up with x equals 1/2. And then here I'm going to subtract 3 from both sides. So I end up with x equals -3. So don't forget your original one that worked. I have a 0 at 1, I've got a 0 at 1/2, and I have a 0 at -3. So the key there is find all your possibilities and then just start guessing and checking until you get one that works. You may have to find more than one that works. Like, for instance, on this next example, I've got a 4th degree. So before I get a quadratic, I need to have found 2 zeros to get a quadratic answer. So here, starting with all my possibilities, I'm going to have 27, or the factors of 27, over the factors of 1, which that works out kind of nice because then you'll just have whole numbers or your possible rational roots. So I'll have 1 and 27 and 3 and 9. And remember, plus or minus all of those. So those are all my possibilities. So again, we're just going to start. I'll start with -1. I'm in descending order and I don't have any missing terms, so I'm going to do 1, -2, 6, -18, and -27. So bring down my 1. 1 times -1 is -1. -3 times -1 is +3. Bring down the 9. -9. That will give me a -27. And then when I multiply that by the -1, I get a +27. So I actually guessed good the first time. And so my -1 is a 0. So what that means is that this answer is x cubed minus 3x squared plus 9x minus 27. So I still want to find another 0 that works so I can get it down to a quadratic by dividing out one more. And I'm just, instead of starting completely over, you can just start from the answer to your first 0. So I'm going to start there. I'm going to try 1 now. So 1 times 1 is 1. Subtract, or add, sorry. This one does not work. because I don't get a zero remainder. So that doesn't work. So I'm still going to use these numbers and try another possibility. So I'm going to use 1, -3, 9, and -27. And let's move over and try a -3. No, don't do that. Bring down the 1 and then multiply. So that is 27. And that is definitely not going to give me a remainder of 0. So my -3 doesn't work. So let's try a +3. And yes, this is what you're going to have to do. You're going to have to just guess and check until you get the correct zeros. I actually think this one might work. And it does. So I found another 0 at 3. Now, if you go through this process and you can't find another one, you might have a repeated 0. I don't in this case because I found another one, and then this gives me the quadratic x squared plus 0x plus 9. But if you run out of all your possibilities, if you've checked them all and they don't come out, you might try dividing again by the same 0. It could be a repeated 0. But in this case, I end up with x squared plus 9. And then you can set that equal to 0 and square root both sides. So I get x equals plus or minus 3i as my other two factors or zeros. So my zeros are -1, 3, -3i, and +3i. Those are my 4 zeros for f of x.